My name is Fernanda Margarido. I am a professor at IST Lisbon, Portugal. I teach recycling of end-of-life products and I do research also in the same area. In my free times, I go to cinema, I read books and I do arts and crafts, basically ceramics. Hi and welcome back. In the first video, I talk about life cycle assessment (LCA). In this video, we'll explore methods for product change and value chain management. We look at methods such as supply chain management, carbon and water footprint, environmental product declaration, and design for environment. The typical flowchart of supply chain management can be seen here. There are many definitions of supply chain management. One of them is the system of organizations, people, activities, information and resources involved in moving a product or service from supplier to customer. Supply chain activities transform raw materials and components into finished product that is delivered to the end customer. The fundamental objective of supply chain management is to add value, and its scope is multi-dimensions. The most important thing is to understand the customer's needs. Companies that want to improve their competitive position by reducing their order-to-delivery cycle can use supply chain management to help them. Three types of management flows of supply chain management are product and service, information, and financial. However, there are some supply chain risks like disruption, quality issues, and loss of control of sensitive information. The advantages of supply chain management are in terms of economic benefits, competitive advantage, process innovation, and improved public image. The alternatives to supply chain management are outsourcing, where companies can transfer or contract some or all of non-productive internal processes. And why do firms outsource? They do this for financial, cost, and revenue reasons. When companies outsource, there can be some benefits like decreased prices and focus on its core strength, on conversion of some fixed costs into variable costs. However, there are some risks like loss of jobs, lower productivity, or knowledge transfer and intellectual property concerns. Now we turn to the concept of carbon and water footprint. Both are environmental pressure indicators, measuring people's use of natural resources and the anthropogenic emission of compounds into the environment. Carbon and water footprint are useful measures for policymakers who are working to address overexploitation of natural resources and the planet's carrying capacity. Carbon footprint is the total set of greenhouse gases emissions caused directly and indirectly by a person, organization, event, or product. It is measured in terms of carbon dioxide equivalents, or global warming potential. It is comprised of greenhouse gases like carbon dioxide, methane, sulfur hexafluoride. Carbon footprint is not a true LCA because it only models one impact category, the climate change. Carbon footprint can be analyzed through three different scopes: direct emissions, which includes combustion sources; indirect emissions, that includes consumption of purchased utilities; and other indirect emissions from activities of the company, such as transportation of waste. Carbon footprint is a standardized procedure according to the ISO 14060 that sets out several aspects related with greenhouse gases emissions. Water footprint is the total volume of water needed to make a product or to be consumed in a process. Water is becoming more scarce and expensive. Climate change and other stresses are limiting the availability of clean water and affordable energy. Water footprint shows human consumption and contamination of freshwater resources. Water footprint consists of three components. The first two are blue and green, which relates to the consumption of water resources. The third is grey, which is the volume of fresh water that is required to assimilate the load of pollutants based on water quality standards. Water and carbon footprint can be complementary tools. However, some key differences remain. These differences are in terms of spatial and temporal dimension, specific or average values, supply chain, and so on. Environmental Product Declaration (EPD) is an independently documented report containing environmental data of products or systems based on LCA. EPD is organized using a common methodology and is in accordance with the International Standard for Labels ISO 14025. LCA is a method and EPD is a report. For each product group, rules are developed called Product Category Rules, PCR. These control the calculations and data collection requirements between product categories. It enables the creation of an EPD. PCR is included in ISO 40025. The process for implementing an EPD is made up of three steps: product category rules, life cycle assessment, and the environmental product declaration. EPD may be used for many different applications, such as green public procurement, eco-design, or environmental management systems, such as business-to-business communication. 70% of a product environmental impacts results from the design stage. To reduce these early negative impacts, we can think in terms of life cycle engineering, meaning the engineering and design of products and process to minimize the cost and the environmental impact for all life cycle phases of a product. We call this design for the environment or design for sustainability. The key principles of design for the environment are efficient design, cyclic design, safe design, and communications design to encourage responsible consumer behavior. This slide describes the guidelines of design for the environment and also the materials that are used for the manufacturing of products. We see that with good design for the environment, we should not combine materials which are incompatible for recycling. And for materials, the guidelines should include recycled and recyclable materials. Design for the environment provides substantial benefits for manufacturers, like reducing production costs, identifying new business opportunities, and so on. We now turn to look at a case example that illustrates some of these concepts.
CECIL wants to be a very sustainable cement producer company. So we have to regard very carefully with carbon and with water and also other KPIs. We are within the European Trading Scheme. Besides that, CECIL is a member of CSI, the Cement Sustainable Initiative, and now on the Global Concrete and Cement Association. So we have international commitments, we have international goals we have to fulfill. They are the reduction of water, the reduction of CO2 emissions, and the improvement of alternative fuels to a higher rate than the one we have now. We have here in this plant about 55% of consumption of alternative fuels, and we want to reach 70% by 2020. In concerning to water, we want to reduce our consumption of water and manage all the life cycle of water. In the last years, we can notice an important improvement in the environmental performance of the plant. We have introduced in 2004 the alternative fuels, and that was a major change in environmental management of the plants. and we have a very good system of filters, so we have a very low level of dust emissions. And we carefully take care of the biodiversity in our quarry, which is in a national park, so we have to be very careful with nature and with the environment.
A sustainable future is possible, and design for the environment is a key strategy to help manufacturers to achieve it. That concludes our look at Level 2 of the CapSEM model. Next video in this series, we learn about Level 3, Organizational Change for Improvement. Thank you for your attention.